Today, we're stepping into one of those everyday mysteries most of us never pause to think about. Fire. We see it sway on the tip of a candle, roar from a campfire, or crackle inside a fireplace. It's beautiful, dangerous, and comforting all at once. But what is fire, really? Is it a solid? A gas? A form of plasma? Or something else entirely? Why does it shine? Why does it move the way it does? For something so common, fire is surprisingly misunderstood. Let's clear up one big misconception right away. Fire is not a substance. It's not a thing you can scoop up, bottle, or keep on a shelf. Fire is a chemical event, a process in motion, not a physical object. The flame you see is simply the visible outcome of that reaction. Think of it like a rainbow. A rainbow isn't an object either, it's what happens when light bends through tiny droplets of water. You can't grab a rainbow, and in the same way, you can't truly hold fire. Fire exists only when three essential ingredients come together, something scientists call the fire triangle: heat, fuel, and oxygen. You need something that can burn, like wood, oil, or gas. You need a spark or heat source to kick things off. And you need oxygen, usually supplied by the surrounding air, to keep the reaction alive. Take away even one of these elements, and the fire instantly disappears. No fuel, no oxygen, no heat, no flame. Now this is where things start to get truly fascinating. What is that bright, glowing part of a flame actually made of? When something burns, let's take wood as an example, the heat doesn't just consume it. It breaks it apart. The complex molecules inside the wood begin to fall apart under intense heat, splitting into simpler substances. In the process, gases are released, including carbon dioxide, carbon monoxide, water vapor, and various hydrocarbons. These newly formed gases are extremely hot, so they rise upward and mix with the oxygen in the surrounding air. Right at that boundary, where hot gases meet fresh oxygen, the flame becomes visible. So the flame itself is made mostly of gas. But not ordinary gas. These gases are in a highly energized, excited state. When they become hot enough, the atoms and molecules inside them start releasing energy. That energy escapes as light. This is why a flame glows, its hot gas shedding energy in the form of visible light. The familiar yellow glow of a candle flame comes from something slightly different. Tiny particles of soot, microscopic bits of carbon, form during the burn. These particles heat up until they glow, much like miniature embers floating in the air, radiating that warm yellow light. On the other hand, flames that burn more cleanly, such as those from alcohol burners or gas stoves, often appear blue. That's because they create far less soot. Instead of glowing carbon particles, the color comes directly from excited gas molecules releasing light. Cleaner burn, different glow. You may have heard people describe fire as a type of plasma, the so-called fourth state of matter, beyond solids, liquids, and gases. That idea isn't completely wrong, but it's not the full story either. When temperatures climb extremely high, like inside a welding torch or during a lightning strike, the gases involved can become ionized. That means atoms lose some of their electrons and turn into charged particles. And that condition fits the scientific definition of plasma. In those extreme cases, fire does contain plasma. But a normal flame, like the one on a candle, doesn't get nearly hot enough for that to happen. Most everyday fire is simply a mix of hot gases and glowing soot particles, not plasma. So while plasma can appear in certain intense, high-energy fires, it's not a defining feature of fire itself. It shows up only under special conditions. Now, let's shift our focus to something you've definitely noticed before: the color. We usually picture fire as orange or yellow, but flames can actually glow in a wide range of colors. And the reason all comes down to what's burning. That's because every element gives off its own specific wavelengths of light when it's heated. You can think of it as a kind of glowing fingerprint. Each element has its own light signature. Burn copper, and the flame takes on a green hue. Sodium produces that intense, familiar yellow. Potassium glows with shades of purple. This is the same reason fireworks explode into brilliant colors across the sky. Those colors aren't random or decorative by chance. They're the result of carefully chosen elements reacting in fire. Fireworks designers are, quite literally, using chemistry to paint pictures in the air. Because of this, the color of a flame can reveal a lot about what's burning and how hot the fire is. Blue flames usually indicate a cleaner, more efficient burn, higher temperatures and very little soot. Orange and yellow flames tend to be cooler and messier, filled with tiny glowing carbon particles. Now here's another question many people have wondered about. Why does fire flicker? Why doesn't it stay steady, like a light bulb? The answer lies in how sensitive fire is to moving air. Hot gases naturally rise, and as they do, cooler air rushes in to replace them. This constant flow of air, combined with turbulence and small changes in fuel supply, causes the flame to dance, twist, and pulse. Fire is always responding to its surroundings, never holding still. That's exactly why a candle suddenly flares near an open window, and why a campfire seems to dance when the wind picks up. Fire is incredibly responsive to its surroundings. It's never frozen in place. It flows, it shifts, it reacts to every change in the air around it. Because of this behavior, fire can feel almost alive. Which leads to a surprisingly common and poetic question: is fire alive? It breathes in oxygen. It feeds on fuel. It grows, spreads, and eventually dies out. On the surface, it checks a lot of boxes. But the answer is no. Fire isn't alive. It has no cells, no DNA, and no way to reproduce the way living organisms do. It may behave like something living, but at its core, it's purely chemical. Fire has no intention, no awareness. It doesn't choose to burn, it simply obeys the laws of physics and chemistry. Even so, it's easy to understand why ancient civilizations saw fire as a living spirit or force of nature. It's mesmerizing, powerful, and strangely organic in the way it moves. So, what is fire actually made of? It's a swirling combination of heat, light, energy, and gas, all bound together in a delicate chemical reaction. Fire isn't a thing you can hold, it's a process. A release of energy that happens when matter transforms, often in dramatic and beautiful ways. Even though fire is one of the oldest tools known to humanity, it remains something truly remarkable. It helped shape civilization itself, providing warmth, enabling cooked food, forging tools, and bringing the very first light into the darkness. And yet, no matter how familiar it becomes, we still find ourselves staring into it, watching it move, trying to understand its mystery. So the next time you strike a match or sit beside a campfire, remember this: you're not just looking at a flame. You're watching a delicate dance of molecules, the glow of energized atoms, and a process as ancient as the stars in the sky. Thank you for watching. If you have ideas for future videos, share them in the comments below, we'd love to hear from you. And don't forget to like, subscribe, and stay tuned for more stories hidden inside the simplest things.